So we all know that heat energy and heat transfer are an integral part of our everyday life. We may not realize it or more obviously, but yes, it's a hidden and integral part of our life. Like a few common uses of heat energy, if you see, it's to cook food, boil liquids, which is a regular phenomenon in our households, to separate components with different boiling points, distillation in short, which is again related with the heating of the fluid, so that the low boilings and the heaviers are separated as part of the distillation process. It's used to melt metals and form them into different shapes for use in vehicles, utensils, or any other applications. Even a thermal power plant is to generate electricity. Heat transfer is an integral part of that. So heat transfer is it's again important because we need to make efficient use of the heat energy. Heating and cooling of process fluids is a in a process plant to and maintain the desired product yield. It's a part of any process plant. Energy conservation, because your efficiency and energy conservation are interrelated. So that to have efficient operations, we need to conserve energy. Heat energy is a major form. Maintaining our living spaces, either our offices or our homes, at comfortable temperatures. Your air conditioners, they are a part of heat exchangers. Regulating our body temperature, that's also our body itself is a heat exchanger. These are some common examples of heat transfer applications. Your refrigerator, your automobile radiator, where the fluid is cooled by air. This is a good example of an air cooler, though the form is different slightly. Then the microwave oven, which we use regularly at homes, this is also a heat transfer equipment. A very good example in an industrial application is your cooling tower, where actually in a cooling tower, both heat and mass transfer are involved because the air and water are in direct contact. So both heat and mass transfer take place in the cooling tower. Another industrial application is your fired heaters, which are used in refineries. Though in a fired heater, it is never cooling is never involved. It's always heating up of your product of your feed. If it's a crude oil heater. If it's something like a heating oil like Dowdam or Therminol, it's a Dowdam heater. But it's always heating up of the fluids in a fired heater. Unlike in shell and tube or air coolers, where it can be both ways. Either you are heating a product or cooling a product. Then this is a perfect example of a closed loop feed water system, where water is pumped to the boiler through a feed water pump, and the boiler has a heat input to it, either in the form of combustion of any fuel. It's a gas or solid fuel, liquid fuel, or a gas fuel. And because of the heat pickup in the boiler, you generate high pressure steam, which is going to a turbine, which is generating power. And the turbine exhaust, which is your low pressure steam, is fed to a condenser, which is again a heat exchanger. So the boiler is a fired heat transfer equipment here, and the condenser is an unfired heat transfer equipment here. And this is an example of a fired heater. Generally, the representation shown here is I'd say it's a helical coil thermic fluid heater system.